Hello students, the question says the average speed of a bus x kilometer per hour on a certain journey is a continuous random variable with the probability density function given as fx equals to k by x squared, where x is lying between 20 and 28 and is 0 the otherwise. So the first part of the question says show that the value of the constant k is 70. So to answer this, we must know that the sum of the probabilities this should be equal to 1. So sum means integration. So we'll integrate the given probability density function from the limits 20 to 28, and that should be equal to 1. So the lower limit should be 20, the upper limit should be 28. K being a constant can be kept outside the integral, and that becomes dx by x squared, and that should be equal to 1. So if I integrate using the formula x to the power n dx, so we'll get it as k outside. So that can be written as x to the power minus 2 dx, ranging from 20 to 28. So applying the formula of the power rule of integration, which states that x to the power n dx equals to x to the power n plus 1 by n plus 1 plus the integral constant c. We'll apply the same form over here. So this should be equal to 1. So again, if I integrate this part, so I'll get x to the power minus 2 plus 1 by minus 2 plus 1, ranging the values from 28 to 20, and that should be equal to 1 and the constant k outside. So if I solve this out, so I'll get k into minus 1 by x, and that should be equal to 1, the lower limit being 20 and the upper limit being 28. So if I put the things here, so I'll get k into 1 by 20 minus 1 by 28 should be equal to 1. So if I take up an LCM and solve this out, so I'll get k equals to 70, and that's the answer for the first part of the question. Now, moving on to the second part of the question, it says that find the EX. EX means the expected value, or even known as mean. So to answer the second part of the question, the PDF function is given to us. That's the probability distribution function. So that is from 20 to 28. So the formula to get the mean or the expected value is x into fx dx, ranging from the given values. So we know the value of k here, so we can put the value of k as 70. So the range of the function again starts from 20 and ends at 28. So the lower limit will be 20, the upper limit will be 28, and x into fx, which is 1 by x squared dx. So we can see that one of the x gets cancelled. So we are left out with 70, 20 to 28 dx by x. So if we apply the integration formula, so that should be ln x ranging from 28 to 20. So if I solve this out, so that can be written as 70 ln 28 by 20. So that can be 7 by 5. So 70 ln 7 by 5, which is 1.4. So if I put it into the calculator, so the answer that I get nearly is about 23.5. So that's the expected value of the given probability density function. Now, moving on to the third part of the question, it says that find the probability of x less than ex. So the third part of the question, probability of a random variable x less than the expected value. So in the last question, we calculated the expected value as 23.5. That was our expected value. So that means we have to integrate the given function. The k value is 70, which we already found out. So integration sign, the lower limit will be 20, and the higher limit will go up till the expected value, which is 23.5, and our fx function should be dx by x squared in that case. So again, applying the power rule formula, and it's ranging from 20 to 23.5. So that should be equal to minus 1 by x, again ranging from 23.5 to 20. So if I solve this out, so I'll get an answer which is approximately equal to 0.528. Now that's the probability value of a random variable x less than the expected value. Now moving on to the fourth part of the question, it says that hence determine whether the mean is greater than or less than the median. So median value is 0.5, that's the middlemost value. Now mean we can always see, thus now we have calculated the value of mean which was 0.528. The probability of a random variable x which is less than mean, less than expected value. So it is greater than 0.5. So we can say that yes, mean is greater than median because the probability value of less than mean type is greater than 0.5. So mean will be greater than the median. So this will be the solution for all the four parts. Thank you, students.